concept you can see Ampere circuit law and its applications. According to this law, line integral of the line integral of magnetic field, line integral of magnetic field along a closed loop, along a closed loop, along a closed loop is equal to mu naught times the sum of steady currents, the sum of steady currents, the sum of steady currents threading the closing loop, threading the closing loop. So in equation point of view, the line integral of closed integral of so b bar dot dl bar that must equal to so mu naught times of I enclosed, I enclosed by the surface. Now it is valid for the DC current as well as certain amount of elements like resistor, inductors. So it will be valid. Now we'll go with the just current is connected to capacitors. See, let us you can take in it is your capacitor. It is your capacitor, and here we need to connect whether it is a AC voltage, AC or DC, whatever it may be, you can take it. So AC or DC, you can take. Now, let us if you take in it is your positive plate and it is your negative plate. Then definitely, so on this plate, total positive charge will be up here. On this plate, a negative charge will be up here. No doubt about it. Now here you can see I've taken one cross section. So one cross section. So like this, it is encloses with the surface. Like this, I'll take in one closed surface. Like this. Now let us you can take in it is your surface is A1 and here you can take in surface is A2. Two different surfaces. So let us you can take in it is your surface is A1 and it is your surface. Now two different points you need to consider. So two different points we consider, that is here one point, let us you can take in point is 1 and here you can take in point is 2. Inside the surface A1 1 point and inside the surface A2 1 point. So definitely if your circuit is closed now, so big high amount of current will be set up and here and here. So high amount of current will be set up. Because of this one, magnetic field at 2 does not equal to 0. Already we know that according to Ampere's. So closed integral of B bar dot dl bar does not equal to 0. Why? Because enclosed current is I. But here in this in between the plates there is no current, but in between the plates, in between the plates there is no current, there is no current, but but there is no direct current. But magnetic field at the location of 1 also does not equal to 0. Okay, so we will observe the magnetic field in between the plates. It will be still available if there is no current. That's why Ampere law will be fails to explain this concept. So if there is no current also, magnetic field will be available in the location of A1 or in the location of 1 point. So this is can't explained by the basic law of Ampere's. That's why Maxwell will give idea about changing magnetic field. So Maxwell gives the idea change in electric field, change in electric field will produce electric field will produce magnetic field, changing magnetic field. So changing electric field produce changing magnetic field. So applying this concept, and he is given a new formulations for the ampere, change in magnetic field. So apply this concept, we are applying to change ampere circuit law is called as modified forms of ampere. We will go with the next topic. Next concept, displacement current. So displacement current is a current. So it is a current which is produced, which is produced, which is produced due to the rate of, due to the rate of, the rate of change of electric flux, change of electric flux, electric flux with respect to time, with respect to, okay. So in the definition oriented point of view, drift current ID equal, displacement current ID equal to epsilon naught times of d by dt of, so d by dt of electric flux by E. So we will formulate this formula with the help of capacitors. You know, to calculate this one, so first we need to take in one capacitor, one capacitor. I'm connected to this one an EMF source, connected to this capacitor to an EMF source. Let us you can take in it is a positive and it is a negative, and it is your EMF source. Now if it is positive plate is connected now, so here positive charges will be accommodated and here negative charges will be accommodated. And at any instant of time, at any instant of time, the charge present on the, so at a time t after closing the EMF source, at a time t, the charge on the capacitor plates, the charge on capacitor plates, the charge on capacitor plates is, let us you can take an it is a plus q and it is a minus. Then electric field develop between the plates of a capacitor. Then, so here electric field will be set up from positive plate to negative plate. The electric field between the plates of a capacitor. That is, you can take in Q. So electric field produced between the plates of a capacitor. Between the plates of a capacitor. So what do you got? Electric field E equal to, so already we know that sigma divided by epsilon. Why? Because both are field due to positive charge and field due to negative charge if you are considering a sigma divided by epsilon. So from this equation, sigma is nothing but charge per unit area into epsilon. From this equation, you can take in charge appearing on the plate is nothing but charge appearing on the plate, or simply you can take this is equation number. Okay. From this equation, flux through, already you got this equation and this one, and you can take in flux through capacitor. Just you can take an electric flux between the plates of a capacitor. You can take that is electric field times of area of cross section A1 bar. Therefore, you can take an electric field is, so Q divided by A times of epsilon naught times of area. Therefore, area and area get cancelled. Na? You got electric flux. So here I need to write. So electric flux that is pi E, that is you can take in charge times of field. From this equation, cross multiply this equation, you got charge accumulated on the plates of a capacitor is pi times of electric flux changes, electric flux in between the capacitors. Now here you can differentiate on both sides with respect to time. Differentiate on both sides with respect to time. Then what you got? So dq by dt. So dq by dt that must equal to permittivity between the plates of a capacitor resonance constant d phi e by dt. So dq by dt rate of accumulation of charge on the plates of a capacitor you got Brief displacement current. Displacement current equal to E naught times of d by E divided by dt. Now, this equation we need to take in as displacement current between the plates of a capacitor. Okay, and this displacement current having a certain amount of properties, like a displacement current arises due to the rate of change of electric flux or electric field between the plates of a capacitor, and the displacement current is equals to the conduction current. So certain points we need to remember. Displacement current between the plates of a capacitor is nothing but a conduction current within the circuit, and both will be present in different forms but equal. Next, conduction current and displacement current are individually discontinuous. Why? Because up to this plate, conduction current will be present. So conduction current. In between the plates, displacement current will be present. And again, conduction current will be present. So both are discontinuous. However, the current together possess the property of continuity throughout the closed circuits. Just like a conduction current and displacement current act as a source of varying magnetic field. And here, because of here if you take Nashvi as a point one, so because of conduction current, magnetic field will be set up. And if you taken here a point number two, at the point number two, because of the displacement current, magnetic field will be set up. Okay, these are all the points we need to remember belongs to displacement current. I mentioned over here, the displacement current arises due to the rate of change of electric flux or electric field between the plates of a capacitor. Displacement current is equals to the conduction current when both are present in different parts of a circuit. The conduction current and the displacement current are individually discontinuous. However, the current together possess the property of continuity throughout a closed electric circuit. Just like a conduction current, displacement current or current act as a source of varying magnetic field. Okay. Next, you can see the concept of Maxwell's equations. So here, basic four different equations are there. First one is Gauss law for electrostatics. According to this one, closed integral E bar dot dl bar equal to Q enclosed by epsilon. In other words, Maxwell's first equation. In other words, the net electric flux path associated with any closed plate. The net electric flux. The net electric flux associated with associated with any associated with any closed loop that must equal to q enclosed by epsilon. Q enclosed by epsilon. This law relates electric field, which is charge distribution. Electric charge distribution. And the Gauss law is a uh, Gauss law in accordance with the Coulomb's law, inverse square law, which has experimentally confirmed. Okay. Next, you can go with the Gauss law for magnetism. So, and here, Gauss law for magnetism point of view, the net magnetic flux associated with any closed surface. See, the net magnetic flux, the net magnetic flux associated with associated with any closed loop, any closed loop that must equal to zero. So, which gives the basic concept. There is no availability of monopoles. So, lastly, we need to write one thing. Because of based on this one, there is no existence of isolated magnetic poles. So means we don't have we don't have isolated magnetic poles, isolated magnetic monopoles, magnetic monopoles. Last one, Faraday's law of EMI. According to Faraday's law EMI, the line integral of electric field, the line integral of electric field, E bar, the line integral of electric field along a closed path, along a closed path, along a closed path is equal to the rate of change of magnetic flux, rate of change of magnetic flux. Magnetic flux. So that is you can take in Faraday's law of induction. And last one, we can go with Ampere's Maxwell's circuit law. First, it is we need to recall it is Ampere's law. According to Ampere's law, closed integral b bar dot dl bar equal to 0 means the line integral of magnetic field along a closed path is equals to mu naught times of conduction current. After invention of displacement current, Ampere circuit law will be modified as Maxwell's Ampere circuit law. So according to this one, the line integral of the line integral of magnetic field, magnetic field along a loop, along a closed loop equal to mu naught times. So mu naught times displacement current plus conduction current. Where displacement current is a formula we are deriving, that is permittivity of displaced times of d pi e electric flux divided by dt. So it is converse. A changing electric field will produces changing magnetic field, and changing magnetic field will be produces changes in electric field. Because of this one, both electric field and magnetic field both are correlated to each other. We are predicted. Okay, this is the Maxwell's circuit. Next, sources of electromagnetic waves. So simple, very one basic concept you can keep in mind. Accelerated charges. So accelerated charges produces produces electric field and magnetic field, and along between them some radiation is also emitted. Electric field and magnetic field and electromagnetic waves. So sources of electromagnetic waves is just accelerated charges. So accelerated charges in different apparatus. So if you are predicted na, then electromagnetic waves will be produced. See, first source, an accelerating charge produces both electric field and magnetic field, which varies with time and space, which forms electromagnetic waves. That is the first basic idea. So this is the only concept, accelerated charges. So this is the only phenomenon which produces electromagnetic waves. In an accelerated charge in LC oscillations, see, LC oscillations also charge will be oscillating with respect to time. Okay, next, certain amount of next we need to take an electron orbiting in a stationary orbit. See, an orbiting electron is also possesses certain amount of acceleration called as a centripetal acceleration. That is produces mv square divided by r. It is a centripetal force, and it is also taken centripetal acceleration. So it is also got centripetal acceleration, and the circulating electrons is also belongs to accelerated motion only. Then circulating electrons also produces electromagnetic waves. Last one, see, when high speed electrons when high speed electrons enters into a target of high atomic weights, then because of repulsion between the electron to electron speed will be decreasing with respect to time, and here also acceleration will be produces because of the coulombic attractions or coulombic repulsion. Then here also electromagnetic waves will be produced, and electromagnetic waves will be producing due to de-excitation of the nucleus. So de-excitation of the nucleus, in that process, certain amount of radiations will be produces, that is a gamma rays. Okay, so these are all basic sources of electromagnetic waves. In all these cases, the only phenomenon will be occur is accelerating charges. Accelerating charges produces electromagnetic waves. That's it. Next concept, plain progressive electromagnetic wave. So here, electromagnetic wave at any point in space, electric field and magnetic field are sinusoidal functions of at any instant. And these two are oscillating perpendicular to each other, then electromagnetic wave will be propagating in space. Now, if you are taking electric field, let us you can take in it is your x-axis, x-axis, and if you taken in this direction is y-axis, it is your y-axis. and in this direction we need to take as z axis. So three-dimensional waves. Why? Because electromagnetic waves are three-dimensional waves. How we need to understand this one, you can see now. First, electromagnetic waves will be oscillating along y direction. Electromagnetic waves will be oscillating along y direction. Like this, it will be oscillating. Okay. So having a maximum value of electric field is E naught and the minimum value of electric field you can take in minus E naught. Then magnetic field will be oscillating in z direction. So like this, magnetic field will be oscillating in z direction. Like this, it will be oscillating, and the maximum value of magnetic field you can take in plus V naught, and the minimum value of magnetic field you can take as a minus V naught. Now, electric field is oscillating y direction and y direction, and magnetic field is oscillating x direction. Then electromagnetic wave will be propagating along x direction. So propagation direction of electromagnetic wave is along x direction. So propagation of electromagnetic waves is both perpendicular to electric field as well as magnetic field. Now, if you take in electromagnetic wave is propagating along x-axis, so it will be depends only on domain of trigonometric function of electromagnetic wave or magnetic wave. Now, if you take an electromagnetic wave equation, E bar equal to so E naught times of sine of omega t minus x, where electric field will be oscillating along y direction. So see here the domain of sine. So domain of sine gives the direction of electromagnetic wave. Now, so negative coefficient of x, that is a minus k. If you taken here minus k, the wave will be propagating along positive x direction. If you taken here plus k, then electromagnetic wave will be propagating along negative x direction. Okay, the domain of trigonometric function gives the direction of electromagnetic waves. And similarly, magnetic field is also you can take as a B naught, that is B naught times of sine of omega t minus kx, c times of k cap. See here, domain of sine, it does not changes for electric field and magnetic field. Only the direction of electric field and magnetic field will be changes. So omega t minus kx. Now domain of trigonometry, that is domain of sine theta is remains constant. So that is if you take it as to be as a phase of trigonometric function, phase of sine, then phase of sine is omega t minus kx. In trigonometric functions, both electric field as well as magnetic field will be oscillating with the same phase. Therefore, phase does not changes with respect to time. Now, if you differentiate on both sides with respect to time, differentiate on both sides with respect to time, then you got 0 that must equal to omega times of 1 minus k times of dx by dt. Now, from this equation, you got dx by dt. So dx by dt, that is omega divided by k. So it is the velocity of electromagnetic wave. In first point only we are given all electromagnetic waves will be propagating in the space with the speed of light. That is you can take in. But velocity of this speed of electromagnetic waves will be depends on nature of medium. And if you take in this uh, electric field and magnetic field will be oscillating in a space, na? Then here if you're taking as way as omega divided by k, that is the speed of light. Okay. Further you can go with so here the speed of electromagnetic wave in vacuum. Some points we need to remember here. The speed of electromagnetic wave in vacuum. Speed of electromagnetic wave in vacuum. That is denotes with c, that equal to 1 upon under root. So mu naught times of epsilon naught. This value you can take 3 into 10 to the power of 8 meter per second. 3 into 10 to the power of 8 meter per second. And if you're taking a speed of light in any medium, the speed of light in any medium, the speed of light or speed of electromagnetic wave in in a medium. So in a medium, you can define with V, that equal to 1 upon under root permeability of medium into permittivity of medium. Then you can write this equation 1 upon under root of relative permittivity into permittivity of the space into relative permeability times of permittivity of the space. Then you can define this term in the root. So mu r times of epsilon r into C. So here mu r divided by epsilon r is called as refractive index of the medium, that is C divided by n. From this equation we can see speed of light in any medium that must equal to C divided by n, or the n equal to C divided by V. The ratio of speed of light in vacuum to speed of light in any medium is called as refractive index of the medium. Okay.